Hey there. Welcome back. Welcome back to Chapter 5, Basics of Angles. Here on Angle Talk, we're going to be talking about all different parts of angles and how they go about and how we put things together and then how we can make a very, very nice casserole later. Or actually, maybe we should also make some pie with it. Okay, anyway, moving on. 5.1 Basics of Angles. This is basically to go through and give you guys just some very basic background on how the terminology that we'll be using works. A couple of very basic examples to give you guys a clue on some things. And then, yeah, that's about it. So anyways, basics of angles. Angles are going to have an initial side. This is the starting. This is considered the start, hence the term initial. Kind of like your initials, the starting letter. Terminal side, ending side. Um, yeah, I think we all know what terminal means. Or, you can airplane terminal. That's where the flight ends. You have two ways of measuring angles. Angles can either be measured positively. And it's going to go this way. This is going to be a positive angle measurement. And so for that, that's going counterclockwise. For those of you guys who remember what clocks are, at least non-digital clocks. And then the other direction is a negative angle. That's going to be a negative angle measure. And that's going clockwise. Now those two angles together, generally, not all the time as you will see, because we're going to talk about angles that, the same angle that has more than one measurement, but are generally, if you're doing under 360 degrees, will add up to be 360 degrees. So for example, this angle here might be, what's that, probably about 250, let's call it 250 degrees, which means that the other angle is going to be 110. Oops, sorry, a negative 110. Who got that? Who caught Mr. Hayes in a mistake? Alrighty, moving on. Next on Angle Talk, we're going to talk about measuring angles. When we're measuring angles, what you're going to end up doing is, and this is the way like you'll see latitude and longitude with angles, minutes and degrees, okay, or degrees, minutes, and seconds. So this is degrees. This is minutes. This is seconds. You want to guess how many minutes there are in a degree? Yeah, you in the back. Good. 1 degree equals 60 minutes. I know. Big surprise. Who wants to guess how many minutes or how many seconds there are in 1 minute? So 1 minute equals, yeah, you over there on the side in the red. Good, 60 seconds. It's great having a studio audience here today. So now the question is going to be this, is how are you going to convert from one to the other? And why do you need to do this? It's on things, it's just good general knowledge to know. You've got a couple of options here. So what you're going to do is this. So if I want to convert this to, if I want to go from degrees, minutes, seconds into decimal, that's supposed to be an A. Okay, what you're going to do is this. We have to turn the minutes and the seconds into degrees. You've got a couple of different options for this. Actually, you know what? If you go back a second, ta-da, the magic. So, okay, so 1 minute equals 60 seconds. So then that also means then this. How much does 1 degree equals? 1 degree is going to equal 3,600 seconds, or 60 squared. Think of it that way. So now when it comes time to converting this, now we'll erase it. When it comes time to converting this, what you're going to end up doing is You got 35 degrees plus. Now think about this. This 24 minutes is being broken up into 60 seconds. And this 41 seconds is now being broken up into 60 minutes, which is then being broken up into 60 degree, minutes, and then that's going to be converted into degrees. So you can go 60 squared. So you just type that into your calculator. You could also do it where you could also, I'll show you the other way on the calculator. It's just easier to see it. Come on. Ta-da! There it is. So what you can do is this. So, I mean, for the first one, 35 plus 24 over 60 plus 41 divided by 60 squared. Now, if you're to press the enter key, you'll get your answer. So 35.411388888. It's probably 8 repeating, to be perfectly honest. The other way that sometimes people do it is this. They start with the seconds. So you go 41 seconds divided by 60, because that's going to convert it into minutes. So those 41 seconds are 6.83 repeating degrees, or minutes. We're going to add the minutes on. So now we've got that many minutes. And I'm going to divide that by 60. And then, so that's how many degrees we now have. And then we're going to add in the 35. So notice it's the same answer. Either way works. There's actually also buttons on your calculator that you can also make it go through and do it yourself. So if you can find that, more power to you. So why am I not showing it? Because, you know, you guys have Google. Find it out. Do some work. It's amazing what happens when you do something yourself. You own it. You know? Now what happens if I want to, instead of going from, so again, as I was saying before I got paused and through the magic of recording and editing, blurted that out. Degrees, minutes, seconds into degree, or into decimal. Now what happens if I want to take a decimal and convert it into degrees, minutes, seconds? Why would you want to do this? Well, maybe you're on an old boat. I believe the current Navy has everything in decimals. I could be wrong. Maybe you're on Survivor. I know that's a popular answer. Maybe just 'cause. Who knows? So let's say I've got 200. Actually, I think I've got this on the next slide. Haha, look at that. So what you're going to do is this. You're going to pull off what you don't need. So like here, these are degrees. Okay, so that means it's going to be, my answer is going to be 248 degrees. Now, the question is, what do I do with the 0.772? 0.772. That's now currently in minutes. Now, I have it in degrees, so this is degrees. Let's do a little stoichiometry here, unit conversion. So I'm going to go 60 minutes per 1 degree. The 1 degree will go away. Ooh, I know, cross-cultural or cross-curricular here. Where'd the calculator go? So I'm going to type that in. 0.772. We used to call it 772 thousandths. Times 60 equals 46.32. All right. 46.32 minutes. So now that 46 is going to go up here. So that's degrees. Now I have 46 minutes. And at 32 seconds, 32 minutes, so 0.32 minutes, we need to convert into seconds. So once again, unit conversion. 60 seconds over 1 minute, and I get, dun dun dun, oops, clear, 0.32 times 60, 19.2. That's going to be the last part, 19.2 seconds. So, there you go. Isn't that nice? I thought you'd like that. Now next on Angle Talk, what we're going to be talking about is, well, let's find out. We'll just turn the page. Ooh, trig measures. So when we start doing trig measures, Chapter 5 is going to be all basically right triangle trig. Chapter 6 is going to be dealing with circles and standard positions, and then angles, or Chapter 7 will be proofs. Hey, it's, yeah. Not time to go yet. You're not dismissed. Sit down. I'm not sure if you heard the bell, but that's what it is. Okay, standard measure, standard position. Okay, standard position is with your initial side. The initial side is at 0 degrees. Okay? So you would have one side there, that's your initial side. And then you'll have a coterminal side, or your terminal side, excuse me. So you've got another angle out here, and it can really go, wherever. Quadrant 2, quadrant 3, quadrant 4, go around and around and around and around. And it can also go this way. Okay, so let's say it's here. Boop. And they're going to ask you, and let's say, they're going to give you some information. So, but anyway, standard position is always here. And then you're going to measure it. Generally, more often than not, you're going to measure it in the positive direction. So this is approximately 140 degrees. And they're going to ask you, ooh, how much is it in that direction? And you're like, ooh, hard one, to negative 220 degrees. Then they're going to ask you this. They're going to ask you, write another positive angle measurement for this angle that's not equal to 140. So what you're going to end up doing is you're going to go around the world once and then end here. Okay, so how many degrees are we going to have to add onto that? Yes. No, you in the green. But you're right, add 360 onto that. So you've got 140 plus 360. You can get 500 degrees. And guess what? You could keep doing that over and over and over. And now, you use this stuff well, not you guys probably don't use this stuff, but, skateboarding, slam dunking, X Games. Have you done a 720? There you go, 2 full rotations. Oh, figure skating, maybe. So they're going to ask you this. Now, the thing which that is that those are going to be called, wait for it, boop, coterminal angles. Coterminal angles are angles that share a terminal side, hence the prefix co there. Company, together, codependent, dependent upon each other. Cooperative, working with each other. Okay, so that share a terminal side and are multiples of 360 degrees apart. So, for example, let's say we've got one here. Oops. And you got an angle here. And I tell you, oh, look, that's 75 degrees. And if I ask you to find the least positive in the next least positive coterminal degree, then you're going to go to the smallest positive number that hasn't been used yet. So in this case, you would add 360 degrees onto that. So you're like, oh, look, I now have 435 degrees. Or you could add 360 onto it again. And then you'd get 795 degrees. You could add 360 onto it again. And get 1190 or 55. Oops. Sorry. We here at Angle Talk tend to pride ourselves in correctness. Now you can also go the other direction. If you wanted to go negative, if they ask you for a negative coterminal angle, then you just subtract 360 off of it. So you're going to subtract 360 off of it. We're going to come up with a negative 285 degrees, et cetera, et cetera, et cetera. Now the general form of coterminal angles, we don't do it so much here, but you will use this in pre-calculus. You'll use it in calculus. You'll use this. Well, if you ever drive cross country, I'm sure you're going to use this a couple of times. So it's going to be angle. So like in this case, you'd go 75 degrees plus 360 n degrees, where n equals the number of rotations. And n is an integer, because you can't quite have half of a rotation. Well, you can't be. So if it's a 1, you've gone around 1 extra time. If it's a 2, you've gone around 2 extra time. If it's 10,000, you've gone around 10,000 extra times. You got that. Okay. Now at this point, I'm going to double check. I'm going to move into a different file. All right. So you're going to see problems like this. And these are actually things that you could potentially see on ACT scores or ACT tests. Not to mention, this is actually going to be something fairly, if you do anything with engineering, you may do stuff like this. If you build anything with trucks, cars, whatever. If you have actually, if you happen to have a bike and you have one of those electronic speedometers, this is actually somewhat important because you have to type in when you first set up the speedometer how far away the little magnet that's going around is going. I think you also have to put in the tire diameter, and part of that's so that they can calculate out how fast you're actually going. Because if you do it wrong, you're either going to be going slower or faster than what you're actually going. So Albert has a truck. Why? Because he likes trucks. The wheels are 36 inches in diameter. So, you know what? I was going to use the technology, but there you go. Yeah, something. So 36 inches across. And the wheels are rotating 630 RPMs, revolutions per minute. Find the truck speeds in miles per hour. Well, first of all, what you have to probably figure out is what? Yes. What do you think, Brandon? You're right. Okay, so one revolution equals how many inches? And you can do that by circumference. So circumference is 2 pi r. And generally with these things, well, no, we'll do it. So this is going to be, so you've got a radius of 18 inches. Let's go ahead and change it into feet, because we're going to change this into miles per hour anyway. So this is 3 feet. This is 1.5 feet. You know, I just realized that you're probably thinking, why is he putting minutes and seconds up here? Because those are also the symbols for feet and feet and inches. So if that's 1.5 feet, your circumference is going to be 2 times pi times 1.5. So that's going to be 3 times, or yeah, it does, pi times the diameter. What am I thinking? So that's going to be 3 pi feet per revolution. So that is roughly 3 times pi. Not 3 times clear. Oh my god. There we go. 3 times pi. 9.42. Okay, so we're going to say 9.425 feet per revolution. And then at this point, you're actually going to go through and, again, just giant unit conversion property. So this is the way I do these. So I've got 9.425, and I've got feet per 1 revolution. And then I've got 630 revolutions per minute. So I'm going to put revolutions on the top, so that way I've got that and that. And so what that's going to end up doing is, so they're going to divide out. That's for 1 minute. Oops. 1 minute. And now we've got to change it. So now we've got feet per minute. So we have to change it into miles per hour. So whichever one you want to do first. Let's go ahead and take care of hours. So there's 60 minutes in 1 hour. So now I've got that part taken care of. Check. Now notice here, I've gotten rid of the revolutions. I've got rid of the minutes. So right now my label is going to be feet per hour. So we still need to change this to miles per hour. So I've got miles up on top because that's where I want it. And then I've got hours or miles per feet, and then feet down here. So that is 1 mile is equal to how many feet? Oh, come on, somebody's got to know. Really? Come on. You're right, 5,280. But Mr. Hayes, how am I supposed to know that? Well, you know, it falls into that, hey, it's general knowledge category. So anyway, so now you're just going to multiply all this stuff out. All right, so then from there, it's just a matter of sticking it all in your calculator. So you've got 9.425 feet times 630, revolutions, times 60 minutes. I'm going to pause here and hit enter. So that means that right now you're going, this truck is going 356,265 feet per hour. We're going to divide that by the 5,280. So 67 miles. Ooh, he's speeding in most parts of the world. So sorry. So your answer is going to be 67.5 miles per hour. Okay, so that's how you do those types of problems. Things to work on is this. Okay, 3 through 99, every third problem. 105 through 120, every third problem. Seems like a lot. It really isn't, because you're going to be finding coterminal angles, and how hard is it to add 360 onto something. So with that being said, please use the balance of your time. You should have probably about 20 to 25 minutes, depending upon how many times you paused, to work. For those of you who are doing this in class, I'd like to thank my studio audience and everyone over at the production company for helping me out. And we will see you next time I see you.